All right, today we are going under the hood. We're going to pop the trunk on large language models and really dig into the core settings, the knobs and dials that define how these incredible AIs actually think, create, and talk to us. I mean, you've probably wondered this, right? What is it that makes one AI seem like an absolute genius? Well, another one is, not so much. You can give two models the exact same prompt and get wildly different results. It's not magic, not at all. It all comes down to how we construct and then fine-tune what we're going to call its digital brain. Just think of an LLM as a brain that we get to design from scratch. Every single setting we're about to talk about is a critical piece of that design. So let's start at the very beginning, the construction phase. Before an AI can learn a single thing, it needs a structure. It needs a brain. And the very first decision we have to make is, how big is this brain going to be? And that brings us to model size. Now, in AI, size is measured in something called parameters. The easiest way to think about these is as the neurons and synapses of our digital brain. The more parameters you have, the more powerful its fundamental ability to learn, to spot complex patterns, and to really understand nuance. It's the raw horsepower. And when we say large in large language model, we are not kidding. Some of these models have over 175 billion parameters. That is a mind-boggling number of connections, and it's what gives the AI the raw potential to do everything from writing software to composing music. But it's not just a big, messy blob of parameters. The architecture is really smart. It has specialized components, like attention heads, which let the model focus on different parts of a sentence to understand how words relate to each other. And then you have layers, which create depth. This allows the model to build on simple concepts to understand really, really complex ideas. It's how the brain learns context, not just words. Okay, so we've built the brain. It has all this incredible potential, but right now it's basically an empty shell. It doesn't know anything, so it's time to send it to school. This is the training phase, where our digital brain gets its education. And that education comes from its training data. This is its library. All the books, all the articles, the websites, the code, basically all the text it's ever going to read. And, just like with any student, both the quality of that reading material and the huge volume of it are absolutely essential. Which brings us to maybe the most important rule in AI: garbage in, garbage out. It's that simple. If you feed the model a high-quality diet of accurate, well-structured information, you're going to get reliable, intelligent outputs. But if its library is full of junk, bias, or just plain wrong information, well, you're going to get garbage back. The quality of its education really defines the quality of its thoughts. Training also builds the AI's vocabulary. This isn't just words, but also parts of words we call tokens. The total number of these unique tokens it knows is its vocabulary size. And a bigger vocabulary means it can understand more specialized topics and technical jargon, making it a much more precise and versatile communicator. All right, our digital brain is built, it's educated, it's powerful, and it's knowledgeable. Now we get to the really fun part, actually talking to it. This next section is all about the settings you can use to control the conversation and really shape the AI's personality on the fly. First up is context length. Honestly, the best way to think of this is as the AI's short-term memory. It's how much of the conversation, including everything you've already said, it can hold in its head at one time. A small context length is like talking to someone who keeps forgetting what you said 2 sentences ago. A large one, though, allows for these long, deep, coherent conversations and lets the AI process whole documents at once. And now for my absolute favorite setting, temperature. This is the AI's creativity dial. It lets you control how much risk, how much randomness the model uses when it's picking the next word. Do you want it to be a straight-laced fact-checker? Or do you want to let it get a little wild and be a creative poet? So here's how it works in practice. A low temperature, something close to 0, makes the AI's answers really focused and predictable. It'll almost always pick the most statistically obvious next word, perfect for summarizing a report. But if you crank that temperature up towards 1, you're encouraging it to take a chance on less common words. And that leads to more diverse, creative, and sometimes really surprising results. So for instance, if you asked a high-temperature AI to describe the moon, Instead of just getting, "The moon is Earth's natural satellite," you might get something beautiful and poetic, like this. It's really the difference between reading an encyclopedia and reading a novel. Of course, too much creativity can just become chaos, so we need some guardrails. One of them is called top K sampling. What this does is it forces the AI to only choose its next word from a small, fixed group of the most likely options, like, say, only from the top 5 most probable words. It's a pretty straightforward way to keep things from going completely off the rails. Top sampling is a little more dynamic, a little more clever. Instead of a fixed number of choices, it creates a pool of the top words whose combined probability adds up to a certain percentage, like 90%. This pool can be big or small depending on the situation, which gives you this really nice, flexible balance between being creative and staying coherent. Okay, I know we've covered a lot of ground here, from building the brain to dialing up the creativity. So, to help pull it all together, we've put together a quick little cheat sheet for you. So just think of it like this. Model size, that's its raw brain power. The training data is its library of knowledge. Context length is its short-term memory. Temperature is that all-important creativity dial, and top K and top P, those are its decision strategies. Once you get a feel for these, you can really start to shape the AI you're talking to. And that brings us to one final thought. You now know what's going on under the hood. You have the keys to the control room. You understand the levers that can shape an AI's mind. So the question really is, what kind of AI would you build? A meticulous scientist? A hilarious comedian? A deep philosopher? The choice is becoming more and more yours. Thanks for joining The Explainer.